let's go to page 515, and this is lesson 8.2. This lesson is to use properties of parallelograms. Okay. So a parallelogram is a quadrilateral with both pairs of opposite sides are parallel. So see, so these are parallel and these are parallel. So have two pairs of parallel sides. Okay, the term parallelogram PQRS can be written as the symbol of it as the parallelogram PQRS. In parallelogram PQRS, PQ is parallel to RS and QR is parallel to PS by definition. The theorems below describe other properties of parallelogram. Okay. So over here, theorem 8.3, okay, it says if a quadrilateral is a parallelogram, then its opposites are congruent. So again, if it's parallelogram, then opposites are congruent and opposites are congruent. Okay. So you got two pairs of opposite sides. So again, parallelogram, the opposite are parallel, opposite sides are parallel, opposites are congruent, opposites are congruent. Also, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So again, opposite angles are congruent, opposite angles are congruent. Okay. So it's very easy to remember. So opposite sides are parallel, opposite sides are parallel, opposite sides are congruent, opposite sides are congruent, opposite angles are congruent, opposite angles are congruent. Okay. Okay, now let's go to example 1. Let's go over page 515, example 1. Okay, so you got parallelogram A, B, C, D, and so again the arrow indicate they are parallel. And notice you got one arrow matched with one arrow means the one arrow, these two are parallel, and the two arrows means these two are parallel. Okay, and so you got x plus 4, 12, you got y degree, and 65 degree. So in this case, since opposite sides are congruent, so you got x plus 4 equal to 12. So minus 4 on each side, so you got x equal to 8. Okay. Now for the y, opposite angles are congruent, so y equal to 65. Okay, and that's your answer. Okay. Okay, let's go to page 516. And this is the theorem 8.3. And this is to prove. Okay, so over here it says this is a parallelogram, and you want to prove that the opposite sides are congruent. Okay? Okay, so you have the Q, R, S, okay, PQRS, and okay, so the proofs are given. Okay, and you want to prove PQ is congruent to RS and QR is congruent to PS. Okay, so when you're doing the proof, okay, so here's your statement, and here's a reason. Okay, so step 1, so PQRS is parallelogram, and so this is giving. Okay. So what you want to do is, step 2, you want to go and draw QS. Okay. Okay, so the reason would be so you can, so through any 2 points there, exists exactly one line. Okay, so basically when you have 2 points, you can draw the line. Okay, now once you do that, now you can say that, so first to prove this are congruent, you have to prove the triangles are congruent and use your CP/CTC. Okay, so whenever you have to prove the congruent parts, most of the cases you have to prove the triangles are congruent. Okay, so first I'm going to do this. Okay, so I'm going to just use these two. I'm going to use these two pairs. So since these are parallel and this is transversal, so this angle will be congruent. Okay, so I'm going to say that angle RQS is congruent to angle. Okay, so this one here. Sorry, yeah. So these are alternate angles. Okay, so these two are congruent. Angle QSP. Okay, and now if you now because you look at these two, so these are alternate angles, right? So now you're going to look at these two lines. Okay. Okay. So look at these two lines. So now this would be your alternate interior angle, right? Again, see these two parallel. Okay. So look at these two now. Okay. Okay. So that's your Z. Okay. So that's your. Again, I'm going to color code for you a little bit. So angle PQS is congruent to angle QSR. Okay, and the reason would be these are alternate interior angle. Okay, are congruent. Okay. Okay, so now next thing what we want to do is we're going to use a reflexive. Okay. So we're going to have QS is congruent to QS, and this is reflexive. Okay, because anything is equal to itself. So now you can see that the triangles are congruent because of ASA, right? So you can say triangle PQS is congruent to triangle. Now you have to match up very, very carefully. Okay? So this one, the P does not have any marking, so it match with R. Okay? And Q has a 2 marking, so match with S. And then go to, so PQS, so the one with 1 marking, so go to Q. Okay? And this would be ASA. Okay? So once the two triangles are congruent, then you can say that the PQ is congruent to RS and QR is congruent to PS. And the reason would be CP, CTC. Corresponding parts of a congruent triangle are congruent. Okay? So remember, you have to remember this, right? We did this before. So the clue is whenever you're going to prove that parts are congruent, almost always, or most likely, you have to prove the triangles are congruent. Okay? And after you use a CP, CTC. So that's a good thing to remember. Okay. Now let's go back to the book. Okay. Okay, so now the next theorem, 8.5, it says, here, let's go back up here. Interior angles. The consecutive interior angles, the theorem from page 155 states, if 2 parallel lines are cut by a transversal, then the pair of consecutive interior angles formed are supplementary. Okay? A pair of consecutive angles in parallelogram are like a pair of consecutive interior angles between parallel lines. This similarity suggests theorem 8.5. So when you have parallelogram, okay, the consecutive angle would be supplementary. So again, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So if PQRS is a parallelogram, then angle X plus angle Y equal to 180. So this two would be 180, this would be 180, this two would be 180. Because all these are parallel lines, right? Okay. Now, the parallelogram has a lot of good applications. Okay, for example, like if you have a lamp that can move, right? So this is your parallelogram. So you can even have if you have like a gate, some of the metal gates, they use the parallelogram and they can open and close. Okay, so again, there are real life application of the parallelogram. Okay, so desk lamp, as shown, part of the extending arm of the desk lamp is a parallelogram. The angles of the parallelograms change as the lamp is raised and lowered. From measure of angle BCD, so BCD, looking for this angle up here, when measure of angle ADC is 110. Okay, again, so these are consecutive angles, so they should add up equal to 180. So if this is 110, this has to be 70, right? Because 110 and 70 give you 180. Okay, so just subtract. Okay, here's another theorem. Okay, if a quadratic is a parallelogram, then a diagonal then its diagonals bisect each other. Okay, so again, if you have a parallelogram, and if you draw the diagonals, they would bisect each other. So this would be congruent. This would be congruent. Okay, again, the proof of that is, again, first you prove the triangles are congruent, and then after you use CP/CTC. Okay. Okay, so over here, so in the diagram of parallelogram L, M, and O intersect at the point P. Okay, what is the coordinate of P? Okay, so remember, since the diagonals bisect each other, so this is the midpoint. So P is the midpoint of the O and the M. Okay, so this is the midpoint of these two. This is also midpoint of these two. So that means to find the P, you can average the coordinate of these two, or you can average the coordinate of these two. Okay. Now it's a lot easier if you do the average of these two, because this is 0, 0, right? So over here, the point M has a coordinate of, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So 1, 2, 3, 4. Okay. So double check 1, 2. So, yeah. Okay. And the O is a 0, 0. So you average the two, so the P would be average of the two, so it would be 7 over 2 and 2, right? You add, divide by 2. You add, divide by 2. So it would be, and you have to watch your X and the Y, okay? So 7 over 2, comma 2, so answer would be A. Okay, so answer is A.